I would like to present the results of our research on the topic methods for generating recommendations based on user preferences and video games characteristics. Authors are Oleh, Pavlo, Ilchuk, Oleh, Kots, and Yurii from Lviv Polytechnic National University. The video games industry is currently experiencing rapid development and transformation. Each year, it becomes increasingly dynamic and diverse, providing players with endless options for entertainment and interactive experiences. One of the main challenges facing the video game industry is the large number of games available. According to statistics, today the number of games on Steam, one of the largest platforms for PC gaming, exceeds 30,000. At the same time, the number of games available in the other stores and other platforms is also impressive in its diversity and number. This is compounded by an overwhelming number of new releases, updates, and remasters, which makes the process of choosing a video game extremely difficult for a player. Selecting a game that is interested to the user can be time-consuming and requires significant efforts for players. Recommender systems are designed to simplify the process of selecting video games by providing personalized recommendations that aligns with players' interests and preferences. The utilization of recommender system in the entertainment industry is crucial for several reasons. Content personalization, convenience and time saving, enhance user retention, improvement in profitability, exploring new opportunities, content analysis and improvement. So many algorithms and recommendation methods available today can be categorized into three main types: collaborative filtering, content filtering, and contextual filtering. The most commonly used approaches for generating recommendations by e-commerce companies are popularity-based, quality-based, content-based, based on collaborative filtering, etc. More details of such approaches you can find in our article, and also about matrix factorization for recommendation, deep neural network models for recommendations. Personalization has become a key success factor for online retailers. These businesses are increasingly focused on enhancing personalization, whether by addressing customers by name of their recommendations or by offering special promotions based on individual interests. Recommendations represent the highest level of personalization and are vital for customers and the companies serving them. For customers, the benefits include an enhanced user experience, a sense of being understood and valued, and more tailored offers and promotions. For businesses, the advantages are equally significant: improved customer engagement, substantial customer growth, increased web traffic, and higher sales and revenue. However, despite recommending the importance of high-quality recommendations by online retailers, they have yet to perfect the art of product suggestion. The main issue with current online recommendation systems is that they are primarily behaviorally driven rather than motivational. While many people might play the same game, the reasons for doing so can differ significantly. To improve video game recommendations, it's essential to start by understanding the games you recommend and the reasons behind why players enjoy them. A recommender system typically consists of three key components. Candidate generation is responsible for creating smaller subsets of candidates to recommend the user from a large pool of thousands of products. Evaluation systems is needed to standardize candidate generation from various sources and implement a scoring system to assign scores to each item in the subsets. A ranking system is used after the evaluation process. The system considers additional containers to produce the final ratings. We decided to use three different algorithms to generate recommendations for each user. Two approaches will utilize collaborative filtering, one based on the ALS algorithm and the other using EM and SVD algorithm. Additionally, we will implement a content-based method for recommendations. Characteristics and description of this algorithm as the reason of the selection you can find in full text of our article. Two different datasets are used in our research. Both are available for free on Kaggle and contains data obtained from Steam. We use data for 2023. This first dataset is the user dataset. It contains a user ID, a game name, and behavior, purchase or play, and value associated with the behavior. Figure 3, you can see it on the slide, shows a part of the user dataset. Column headings have been added for convenience based on the data description. The user dataset contains a total of 20,000 rows, including 5,155 unique games and 12,393 unique users. Using the reformatted user dataset, we began to explore and analyze the data stored in it. The main task is to access whether the most purchased games corresponds to the most played games. For each game, we calculated the total number of users and the total time spent in the game by all users. We used the bar chart to better visualize the results for top 20 games with the largest number of users, figure 4. The second dataset is the game dataset. It contains a list of games, their descriptions, URL pointing to the Steam store, package type, single game, bundle, game title, short description, recent reviews, all reviews, release date, developer, publisher with total popular tags, action shooters, etc. Game details, multiplayer, single player, full controller support, languages, achievements, genre, action adventure, RPG, strategy, game description, adult content description, minimum requirements to run the game, recommended requirements, original price and discount price. The dataset contains 51,920 games in total. To compare the different algorithms used to generate recommendations, we created an algorithm that calculates for each user the ratio of the number of games in the user's test dataset that are in the top of 20 recommendations to the total number of games in the user's test dataset. The average value of the ratio for all users is then calculated. This ratio is somewhat underestimated because if a recommendation can't be created for a particular user, the calculated ratio is null. First of all, we created a comparison of the content-based recommendation algorithm with different input data. This is either a column from the original dataset or a combination of different columns. Figure 10 shows the ratio calculated using different inputs. Here, the best results corresponds to using a combination of columns, genre, publisher, and developer. The implementation of content-based recommendations is used in the comparison with the other two collaborative filtering recommendations. We also calculated the ratios for both collaborative filtering recommendations in the same way as described earlier. The results, as well as the results of the retained content-based recommender, are shown in figure 11. As you can see from the table, the best recommender is collaborative recommender with ALS. The performance of the collaborative recommender system is EM and SVD, as well as the content-based recommender system lags far behind it. Let's conclude. As a result of the research, an overview of the latest and most well-known methods, tools, algorithms, and approaches to solving the problem of recommendation generation is made, such as narrow collaborative filtering, variational autoencoder, contextual sequence learning, wide and deep neural network, and DLRM. To analyze user preferences and generate personalized video games recommendations, we proposed three algorithms. A collaborative recommender with ALS, a collaborative recommender with EM and SVD, and a content-based recommender, and analyze their performance result. We used two different datasets for testing, available for free on Kaggle, and contain data obtained from Steam. As a result of our study, the collaborative recommender with ALS performed best. It was implemented in a prototype video game recommender system. Overall, the results of our research are satisfactory. Moreover, it has provided a better understanding of recommender system complexity, stringent requirement, and importance in real life. Of course, there are ways to improve the performance of this model by using more complex algorithms or training it on a better datasets. You can also deepen the system itself by integrating it with the user's Steam account or the history of previous generations. Thank you for your attention.